Okay, we're going to start section 5 now. Before we start section 5, though, I can't say how important this is. It's a sequence of events. And what's a sequence? What comes before 5 is 4. So make sure you've done all the material in 4 before you go to 5. Make sure you work these problems. You're building on a sequence of events. If there's any point along the sequence that you decide you're not going to do, it just makes the next event more difficult. All right, so make sure you've done 4. What does that mean? You've attended the lecture for 4. You paid attention. You studied 4. What do we do? Simple algebraic word problems. We did, certainly before we did the examples, we did 2 examples in the lecture. And then we did the examples in at the whiteboard for you. And the examples that we did were examples 1 through 6, I guess. And then you took at home and you said, well, gee, I think I better practice that. You studied the material and you did these examples in the homework. What does that mean? You went home and have done it. Also, the videos have been published for that. And take a look at the videos if you need to. All right. And make sure you can do that. And with 7 problems there. If you know what you're doing, those 7 problems might take, 10, 15 minutes. Doesn't take long. Sage is optional, but if you want to look at that, you can. All right. So where are we now? We're on this stuff over here. And I just want to point out, this is really the word problems. Although it's old material, you're going to have a WebAssign on this. And certainly don't do this backwards. What a lot of students do is say, I'm not going to bother with anything except for the WebAssign. And that's a mistake. What you're going to do is you're going to do the WebAssign, but before you do the WebAssign, make sure you know what we're discussing over here. It's important for your education to have some sense of what's being discussed in lecture. Not only that, what examples are being presented to you in lecture, and then what examples are you expected to do on your own from the lecture material. And that information is over here for you. Let's go back to the lecture portion. We're not the examples yet. We'll discuss it through. Again, after you finish section 5, do the WebAssign and maybe post something about in a discussion group, something you might think is interesting about what we're doing. All right. There'll be mixture problems. I want to point out, I've been teaching Essex a long time. And what I noticed about their mixture problems, they tend to be quite simplistic. Typically what they do is they take 2 things, mix them together to get a final mixture. All right. That's all they do. We will put that down when we start doing the problems over here. Right now, there's all types of mixture problems, but the bottom line is, here's the deal. They're going to take 2 things, add them together to get a final mixture. And we'll go through that. Again, if you want to read through this over here, there might be some things you might find interesting, but for the most part, it might complicate matters more than it helps. All right. Next up, uniform motion problems. What are we talking about over here? Well, these are uniform motion problems. What does that mean? Traveling at a constant rate for a given amount of time, you're going to cover a distance. What's that relationship? One that you know about already, and that's distance equals rate times time. All right, then we'll do examples. All right, so I'm going to go to the whiteboard. Give me 1 minute to do so. And it's going to be lecture. Lecture's always dry, by the way. I realize that. Now, I want to point out the best thing we could hope for is that you actually start reading a textbook. All right. It really is going to help you greatly. Now, someone says, is it enough for me just to understand what you're talking about? Well, at this level, it is. All right. At this level, it is. So what I'm going to do is just, briefly, not that I want to read to you. I really don't. But we're going to talk about mixture problems. All right. So I'm going to say mixture problems are word problems where items or quantities of different values are mixed together. So I'm just going to say we're mixing things together, right? I recommend using a table or a diagram or a chart to organize the information for each mixture problem you attempt. And you'll see me do this when we start doing word problems, right? Using a table, diagram, chart allows you to think of one number at a time instead of trying to handle a whole mixture problem at once. What's important here is when you're reading, you can understand what you've read. Now, we're going to do a variety of problems. But I want to claim to you, though, when we do these problems over here, They really represent what you're going to get in the web assign and what you're going to be assessed on. Are mixture problems in general more interesting than what suggesting they are? Of course they are. They're also quite difficult. But the bottom line is we're going to do a variety of problems that relate to what we're talking about in class, right? You clearly need to understand what is being mixed together. So what is being mixed together, all right? What's of interest in the mixtures? Generally, it's pretty simple because they hit you on the head with it. For example, if you have two alloys, someone says, I don't know what an alloy is. It says right here, it's a metal mixture, all right? And it says, one of them is called A, weighing 10 pounds and 30% silver. And the other was called B, weighing 20 pounds and 40% silver, right? You should be able to answer the following questions. How many pounds of silver in A, right? So I'm going to say there's 10 pounds times 30%, so it'd be 3 pounds of silver. Now there's 7 pounds of something else, by the way, but there's 3 pounds of silver. You should be able to answer the question about how many pounds of silver in alloy B. Well, there's 20 pounds and it's 40% silver. So it'll be 8 pounds of silver, right? That means there's 12 pounds of something else, but I'm only interested in the silver, by the way. How many pounds would you have in total if you combine the two alloys together? Well, that's simple. You're just adding 10 plus 20, you get 30 pounds of alloy. How many pounds of silver do you have if you add them together? Well, I'd have to look at that. I want to point out what I mean by that. There's 3 pounds here and there's 8 pounds here of silver. So how much silver do we have? 3 plus 8, which 11 pounds of silver mixing together, all right? If you combine alloy A and alloy B together, what percent would be of this alloy B silver? Well, that's pretty simple too, because I want to point out, if you look at it, how many pounds of alloy do we have? Well, we have 30 pounds of alloy. I'll write this down for you. Whoops, let me go back to black. There's 30 pounds of alloy. That's everything. And how many pounds of silver do we have? 11 pounds. So really, what is it? It's 11 out of 30. To convert it to a percent, though, we multiply by 100%. Let me go through that with you. That's written right over here. 11 over 30 times 100%. And by the way, that's approximately 36.7%. Yes, you're allowed to use calculators in some of these problems. They want an approximate, by the way. That's what the little squiggly thing over here means. It's approximate. All right, let's go to the next page. And uniform motion. Just give me 1 second. I'm going to talk about uniform motion now. So let's blow it up. And let me pull it down now. Uniform motion. By the way, typically we do not move uniformly, but we try to simplify this problem, saying that uniform motion is something that's traveling at constant rate. So constant rate's really important, Now, again, the rate may change, but we're going to say for some duration of time, it's traveling at a constant rate. For example, you're driving a car, right? If you're driving a car on cruise control, not that it's perfect, you'd be going at a constant rate if you're using cruise control. Now, I'll be honest with you, I do have my car is old and I do have cruise control on it. It tries to maintain a constant speed, but I'll be honest with you, there is fluctuations. All right. So anyway, let's just simply say constant rate means it's going at a constant rate. So if you set the cruise control at 50 miles per hour, that's a rate, and you drive for 3 hours, you should have a clear understanding that every hour you do 50 miles. And if you drove for 3 hours, you'd be traveling at 150-mile distance. Here's the relationship. And the relationship is distance. And this is for uniform motion equals rate times time. We often abbreviate that with D equals R times T. Okay. word problems are going to be tough. And I do know from experience that students have a difficult time with these distance problems. We're going to try to summarize. Again, when I try to summarize, some people do it by table, some do it by picture. I tend to write the information down. All right. So I want to point out if you're doing a word problem and it's a distance problem, uniform motion problem, I hope you realize there's three things involved. All right, three variables involved. All right, so three variables in terms of constants are one unknown only. All right. Now, so what do you mean three variables? It's either going to be dr and t. But I think you probably know that if we're going to be doing these things, we do have three variables, but typically they're going to be given as two of those to find out the other one. All right. So let's just take a little example here. And it says, if we're going X miles per hour for 3 hours, right, I would write down T is 3. The rate is X, that's at X miles per hour. And the distance would be R times 3x. So I hope you realize that everything is written down, summarized in one unknown now. All right. T is not an unknown, it's 3. R is X and D is 3x. All right. So next thing up, we're going to be doing examples. And I'm hoping they're going to be simple. We just did lecture. Next up, we got to get to the word problems, and we'll go through those examples. After we do the examples, there'll be a supplementary exercises for you to try on your own that are very similar. We're done. And why would you want to do that? To see if you understand what we present to you. All right. Thank you.